Hello, y'all. Coach Johnson here live with you. And chapter number 2. Yeah, we'll turn our swag on. Got a little Coach J Cafe going on. Yeah, gotta love that. I know I broke every rule in the book. Someone, a student actually got this for me. So I got coffee. It's 8:30. There's a thunderstorm, man. We're doing some math. AP stats, actually. Can life be any better? Hey, today a little bit different with the way that you will respond or ask about problems. Please make sure that you post the questions on the YouTube chat right to the right of the screen, and hopefully get those questions answered as soon as possible. The goal of tonight is to do 2 free response. Really, my goal is to do a full test today, to go through a full test. We'll see if we can do that. I may not be able to write every word out, but at the same time, what's cool about that is the fact that we will do as many as we possibly can, okay? If you have any questions, if things start happening, please make sure you text me. Sometimes maybe the internet will goes out or something along those lines, and I want to make sure I'm aware of that. So let me know, and we'll go from there. Sound good? Okay, without further ado, let's get started with some AP stats. I hope you're excited because I'm just Jimmy jacked about this. Excited is definitely a word for it. Okay, so with this being said, I'm going to actually eliminate these right here. I'm going to eliminate these. We're going to come to some of these other problems, but I wanted to just kind of take some time and just assess some of the issues maybe I just heard from today in class, and then kind of go from there. So first of all, let's talk about our height. First of all, we talked about one day where we talked about how the height was what is a probability, and that's what P parentheses means, that the height of our class was greater than I don't know. We're just going to say 100, okay? Now, 100 what? Well, it doesn't really matter in this case. We're just going to kind of make something up. So we're going to say that the mean of 90 was mean was 90 here, okay? Again, this is our also our median. I'm going to review quite a bit here, so just kind of buckle in for these first about 10 minutes, okay? And then we'll get to questions and stuff. But I'm going through a lot because I think it'll help us, okay? All right, so let's say that the problem gives us 90. Now, if this is an FRQ, we've got to make sure we establish context, right? Make sure a good way of doing that is doing it right at the beginning, okay? So if I give you 4 parts to a problem, go right straight into establishing that context. So let's say the mean is 90, and let's say our standard deviation, there's our gang symbol there, is let's say 5, okay? So we got 90, 95, 100, right, and 105, and so on and so forth, right? On my left side, we get 85, 80, right, 75, and we could stop there. So a couple of things that we want to address here. First off, in any FRQ problem, please draw this, okay? It is imperative you draw it, and it is also imperative that once you do it, you set it up in context with it. Now, we kind of already said that. One way to also establish context too is writing it this way, where I could say, all right, find the height that's greater than, or what proportion of the heights are greater than 100. Well, you could write that, but one thing we could also do is just saying P sub, or P parentheses, height is greater than 100. Now, remember that this is not just height is greater than 100, because if I end up going to the right-hand side and I say it's greater than, it will also be greater than or equal to. Now, if I go to the left side, just like with Coach J's height, remember I was in the 3rd percentile? And I said if I'm in the 3rd percentile, that means that 3% of people are less than my height. Remember, I am not included in that. That's very important to know. So this, when it's greater than, we include the equal sign when it's to the right. So the question is what do we do? Well, how do we figure out this problem in the context of what we're doing here? Now, I told you already that there's kind of a multiple ways we could do this. We could do normal CDF, but if we have, by the way, if you do have a multiple choice one, do the calculator version, right? You don't have to show work, just do the calculator version and you'll be good. And remember, this is lower bound, upper bound, mean, and then standard deviation, right? And then we could plug in and go. Some other ways we could do that is finding the z-score of 100, right? So if I found the z-score of 100, I would, just for a practice sake, we'll come back to all this later on, need be, but we know x would be 100. So we got z is equal to 100 minus, and remember when we find our z-score, we call standardizing it, okay? Divide that by 90 or minus 90, and then divide by our standard deviation of 5. So when I do that, I get 10 over 5, which produces a z-score of 2. Now, on your z-score chart, remember that you kind of have this chart here where the proportions are inside, and then on the outside, you've got your z-score. So that's very important that you know how to use that for tomorrow. I'm going to get to a couple other problems that kind of utilize that, but just be sure of that. So we do it from here, and then once I get to this point, I'll find the z-score. The z-score being 2 allows me to see that, again, when I find my proportion only works to the left of that value. So the proportion only works for the green here. But what I know is that in a normal distribution is a form of a density curve, okay? It is a form of a density curve, which a density curve means that there is an area of 1 inside. So remember, the proportional, the whole thing is 1 or 100%, right? But we put it as 1.00. So if we find what the proportion is of the green, we can subtract that from 1 to get what is in yellow. So when I do that for 2, I'll look on my z-score chart. And when I find that on my z-score chart, I recognize the fact that I believe, correct me if I'm wrong, I believe it's 97.5. Right? Is that right? 97.5. Correct me if I'm wrong. Or we call it 0.975. So this is the proportion of the 2 z-score. So I standardize it, found the proportion. I then can take 1 minus 0.975 and produce a value that is 0.025 or 2.5%. Either of those would be good. So 0.025. So 2.5%. So this is the area accumulated within that yellow part right there. Remember, total area would be congruent or equal to 1. Okay? All right, so remember, normal distribution is a form of a density curve. The one thing that I can do with a normal distribution is what we call standardize it. And if I give you a standardized version, the standardized version, we call it a standard normal distribution. All it is this stands for the z-scores that are on here. So this picture would actually be the same as this. Instead of putting 90 here, the 90 has a z-score of 0 because we remember the fact that a z-score is the amount of standard deviations from the mean. And with the 90 being the mean, we know it will have a z-score of 0. We should have known 100 because it's 2 standard deviations to the right of the mean. Therefore, it will have a z-score of positive 2. We should have figured that out before we even saw it because of the fact that we knew it was exactly 2 standard deviations to the right of the mean. So this is just, again, some stuff that I want to throw at you, throw through with you, just so that you could see that there, okay? A couple other things that I want to mention to you. Let's say that this was 100, and we'll just give a basic analysis of this, okay? One of the things that will also need to be understood is the fact that this empirical rule exists 68% between 1 standard deviation to the right and to the left. If it's 2 standard deviations between 70 and, I'm sorry, I went the wrong way. This should be 90, my fault. This should be 80. This should be, hold on. That totally messed that up. My fault, y'all. Went too quick. Let's say the mean is 100. And the standard deviation is 10. So we have 110, 120, and you could even go 130, right? Same thing. So we go 90, this is better, 80, and then 70. The important thing to remember is 68, then between 1 and 2 standard deviations to the right, to the left, that value is 95. And then 3 standard deviations is 99.7. Now, understanding that is important. Understanding how to apply it is even more important. For instance, if I said, what is the proportion of values to the left of 120? Or what is the proportion of values to the left of 130? Or what are the proportion of values between 190 and 120? Well, based on logic, right, we know if 68's in the middle, that means that the values right in here that I'm coloring in red is 68%, or what we would say 0.68 out of 1 as far as the area is concerned. But then we can figure out, well, if this is 68, I remember that 95% is here and here, right? So if we took 95 and subtracted 68, right, we would get, and this is just an example, but this would be 27%. So 27% is here and here. So what we could do is divide that by 2 to produce this value here, and then add that to 0.68 to produce the entire area. You say, Coach, why are you saying this? Well, I just giving you a heads up of some things that could come up in a multiple choice setting that might be important to know. A couple other things to kind of note. Remember, in a normal distribution, again, kind of keeps going to infinity. It's not ever perfect, right? So this area of 1 on the inside is not always perfect, but it's approaching that area of 1. We remember that from today's class, actually. We also remember that the mean and the median are exactly the same, but we use the mean because it's symmetric. Remember that from chapter 1? When it's symmetric, we use that mean, and that's how we produce that that's there. I'm just throwing some stuff out as I check out maybe part of the test here. One thing to remember is, let's say we were doing our height problem again from the previous one, and let's say I did between 70 and 74, right? And I was doing something along those lines. An important thing to remember is that if this height is between 70 and 74, we could make sure, first of all, if I do a normal distribution, first of all, draw it. Second, set it up with mean and standard deviation and shade between 70 and 74. You can use a z-score table to figure this out. And you can also use your calculator, but just be careful on the calculator part moving forward, okay? All right. I think that's it in terms of what I really wanted to hit on. The only other thing I would say is if I said, all right, hey, here's my normal distribution, and I said, okay, what is P of, I'm trying to think of a good example. Oh, let's say that the height is greater than X. Okay, the height's going to be greater than X. And we want to figure out what is and we know that the proportion is 0.48, okay? So what we're saying is that this height is going to be greater than where X is, okay? So we can set this up, let's just say X, and it's 0.48, which is the 48th percentile. We know this is 50 because that's about, well, that is midway right there because that's the mean and median. So we know that the 0.48 is right here. So if I'm solving for X, what X value is in the 0.48 or 48th percentile, I could figure this out by finding the z-score on the z-score table. Where is 0.48? Now remember that this is the opposite, so I'm trying to find this and this from finding 0.48 on the inside. Once I find that, I can set up my formula. I know what my mean is, I know what my standard deviation is, and I'm looking for what X is. And I could find my z-score from this table, plug it in, and then just do some basic math going backwards to figure out what that X value would be. That would be in the 48th percentile, okay? Excellent. And actually, as I look at this, this is height is greater than X. This is my bad. I need to read a little bit better. I made it up and totally messed this up. So if height is greater than X, what we're assuming here, and I'm going to actually erase this just so you can kind of see. If height is the part that's greater than X, then we're saying that right now, the height that's greater than X, so here's X value, is 0.48 or the 48th percentile. So really what I would need is to find what's in green because my z-score table only works on what's to the left of that value of X. So really we would then use 1 minus 0.48 to be able to find that 0.52 is actually the value that I would plug in because that's the green part or to the left of that mean, okay? Excellent. Okay, so I hit on a lot of things there. I know that there's some more stuff that we're going to do. Little shout outs here. Man, I love the fact that y'all are all engaged right now. This is good stuff. FRQ, we're going to go to that. Boom, boom. Yes. Okay. Awesome. Okay. Love the chat. I'm seeing the chats here. Love it. This is, man, this makes my heart happy. This makes my heart happy here. Okay. So let's do the following. Let's go to, got 17 viewers. Nicely done, y'all. Let's go to, oh, yes. Okay. So, yeah, let's go to the first free response here, and let's address this, and we'll talk about context and all that and try to figure out what that looks like, okay? Is this coming up? I'm hoping this is coming up. No, this is not coming up. Hoping this will. Hoping this will kind of come through. See if we can maybe get the, I thought I can get this here. I see that. Let me see if I can actually get this. I'm trying to be able to write on it, and it might not be able to do that for me. That's okay. No, it's not going to work. Okay, that's okay. Just give me just a second. I'm going to take a screenshot of this and see if I can't. Oh, that's perfect. Okay, we're going to do this one, and we'll get down to this one, the free response number 2. So what I'm hearing, y'all, is the free response, the first one. How do I kind of address that? How do I approach that? And so it was a good question. Let's see if we can figure this out. Okay. Let's see. Sorry, y'all. I'm trying to get these screenshots. There we go. Okay. Let me get these on. I just saw something that I love, y'all. Yeah, people are sending me texts of me doing that. This is good. This is good. I love y'all. I do. This is good times. Okay. Let's see here. Let's go here. Screenshots are not working. Sorry, y'all. Let me try to do something real quick. You're not wanting me to do that right there. Okay, let me try this one more time. Let's try this. Try this. Try that there. Okay, I'm going to try to just kind of show you this one and see how I would answer it, and then maybe that will hopefully help us. Maybe it's that. Maybe that was the reason. And I'm just trying to get these pictures up here because I thought I was going to be able to write on it, but for some reason. Try this one more time. Okay, not working. That's okay. So what I'm going to do is I'm going to just show you this one, and then once I show this to you, I'm hoping that this will make a little more sense. Good, good. Okay. Excellent. Okay, so this one, on this problem, there's a couple of things that I want to address. First thing, I want to just kind of show you, and I'll kind of just point as I go. The first thing is I always want to establish context one time through these four, the numbers of 4 here. So what does context mean? I really want to address what is going on here, okay? So let's say in number 1, it says, which range of numbers had the highest percent of students within it? I would start off by saying the amount of money students spent on fast food within a week at GAC showed that the range of number that had the highest percent of students included the $20 to $30 range due to the fact that it increased from 25% to 55% or you could talk about the highest slope. You could talk about something along those lines, but being able to address that answer right there is sufficient. I don't need you to write a book for me, but establishing context throughout that's very important. The second one says interpret a slope of 0, or interpret what a slope of 0 would mean if the next interval was 100 to 110. So what I'm saying is if from 100 to 110 we had a slope of 0, it was just literally a horizontal line. What could I assume on that graph? And explain why. Well, if this goes from 100 to 110, since we already hit 100%, that means that the 100 to 110 would not have anybody within GAC that took this survey or that was a part of this that we surveyed here that spent $100 to $110 on fast food. And we could note that because within cumulative relative frequency, it establishes that the values as we go from 0 to 100%, slowly increases to include everyone, right? So as we look at $60, this $60 does not necessarily mean 50 to 60 is 85%, 90%, right? This means that 80 to 90% of people spend anywhere from $0 to $60 on fast food within a given week. So again, if I have a slope of 0 on one of these, that tells me that there's nobody that actually spends $100 to $110 on fast food. The next one said, Coach Jay spends $40 a week on food. What is his percentile? It's a good question. So if I looked at that, right, I spend $40 a week on food, I would draw something that goes straight up to the top. So right up to the top. And I would draw something that went straight across. Again, we did this on the quiz. Some of you did, maybe some of you didn't, where we did an IQR, if you remember, where I said, okay, 25%, we're going straight across and coming straight down. And then we found IQR by doing Q3 minus Q1. Same holds true here, except now I'm looking at $40. If I spend $40 and I look across, that means that I am in the 65th percentile. What does that mean? That means 65% of people have spend less money on fast food than I do, right? I could say I'm in the top 35%, but this says, what is his percentile? And I kind of already said it, 65%. Draw on the graph, so you would draw something that goes up and down across, and you would just say Coach Jay spending, and you'd be good to go there. This next one I kind of tweaked a little bit. I think it was there's someone in class today that had a great question. I think it was Johnny had a great question about number 4. It didn't really establish context very well, and so I wanted to just kind of do something a little different. So this one says, what amount of money is in the lower 20% of expected purchases on fast food at GAC? So the lower 20% would be right here. And as I go across, there would be kind of $18 there. So you would say, okay, $18, that's great, or $15, I would take it too. But I can't just leave it at 15. Just like with each of these problems, I would restate and say something along these lines. And I'm sorry I can't write on this, just won't let me for this one. But this one I would say the amount of money that's in the lower 20% of expected food purchases in fast food purchases at GAC includes anywhere from $15 or less. So anywhere from $0 to $15, that would be falling in the lower 20 percentile of expected purchases. Now, that was very wordy. I could have tweaked that, maybe condensed that quite a bit, but something along those lines that establishes that we're in the lower 20%, and it also talks about that it's either $18 or lower, $15 or less, something along those lines, okay? Does that make sense? I hope that helps you. If that did help you, just kind of put something on the side, making sure we're good to go, okay? And we'll be good to go. Someone wants me to take a shot, so here we go, backwards. Oh, so close, so close. Let's see buckets. Yeah, Coach Jay for 3. I love it. Okay, so we hit that. We hit that first FRQ. Did it ask for the percent of students? Yeah, I tweaked it a little bit, didn't I? I think I tweaked that a little bit on that one. what amount of money, because we're not talking about what percentage of students, right? If that was in the bottom, we could talk over that. But if you notice on the bottom, it's amount spent. The wording of the problem I didn't like. It was not good. I was actually trying to make it myself this weekend, and it was a bad question. So I tweaked that one. If you go back in this video, you could check that out and go from there. So it's a really good question. Hopefully that makes sense. This is just a bad question on my part. Tweak it a little bit to what it is, still lower 20%. Also be careful if I say higher 20%, you're looking then for the 80th percentile. Just be leery of that, okay? Excellente. Man, appreciate y'all for showing up. Let's go. Oh, yeah, by the way, shout out to my Sweden followers as I get this next one here. Yeah, shout out there. Okay, so let's do this. Let's go to, yes, this is what I want. Okay, so let's do this one. Yeah, the 60 people SRS, SRS of 60 people. I didn't realize that was snuck in there. I had taken this from another test a while back, another version of a test. But what version of, or the SRS of 60 people, we don't know that yet. We're not into that yet. Yeah, you're good to go. So we're not gonna hit on that right now. I guess we could. Well, what could we do? We could say mean of 100. I need to look at that one again. That's not going to be on the test. I think that involves chapter 4 a little bit. I could go back in and just kind of check that out on that one. Yeah, because you don't have enough information. The only thing I would say is that the way that it describes the question, I think it could be maybe described just a little hair better. But really the keys that I wanted to hit on are A, C, and then what would your method of answering be effective the distribution? Yeah, I'd like to just talk about maybe D as well. Let's talk about D first, okay? Yeah, we could maybe do that as well. Yeah, posting the answers on that might be a good thing. I think I just went through the first 4, so let me post these next 4, and we'll actually do these completely through, okay? As if this was an FRQ. So buckle in. We'll do this FRQ together. And Crystal, or if y'all, anyone, whoever needs it, that's either texting me or messaging me. If you need some more on that, let me know by the end, okay? Let's talk about D first, okay? Because that one we could just flat do. B we're going to cross out. So let's go straight to D. It says, would your method of answering A or C be affected if the distribution of IQ scores on this test, oh man, it's late, in the adult population were distinctly non-normal? For example, if they were skewed, explain which parts could be answered the same way, which could not, and how would you know? Yeah, this one is really referring to the fact that when we talk about skewed data, we want to make sure that skewed data addresses median, and skewed data represents IQR, right? Standard deviation and mean are affected if it is skewed, so we would not want to use mean and standard deviation in that case. We would want to use, like I said, IQR or median, right? So let's do this. Let's go through A here. This is the good one. I think this one is one that I'm really, yeah, we just need to go over. It says, what is the probability that a randomly chosen adult has an IQ score on this test over 105, okay? So IQ is above 105, and when we think of above, we think greater than or equal to, and what we're trying to do is find the probability, okay? Hopefully that makes sense. So in this example, this is really what we're trying to find. We also represent the fact that this also, I think, said that it is approximately normal, so we can assume that it's normal. We can use our normal distribution, with 100 being our mean, and standard deviation being 15. So we got 115, we got 130, and 145. The next one, going 15 to the left, would be 85. Next one would be 70, and we would go 55 if it took it that far. So the question that they want us to ask or answer is at 105, which is about right in here, what is the probability of this occurring? Now, what I'd like to do is I'll come back to my calculator here. I'm actually going to do it my calculator way. But if I'm doing it on an FRQ, I want to make sure that, in fact, let's do this. Let's do this. Let's go Z-score on this one. Let's go Z-score on this one, and then the next one I'll do a calculator. Again, show work. That's the key. Show work. Okay, so the Z-score equals X minus my mean divided by my standard deviation. So remember that my X would be 105. And remember, when I'm using this, right, I'm really solving for this area, but I can subtract it by 1 to be able to equal what the part in yellow is. So 105 minus 100 divided by my standard deviation of 15. And when I do that, I get negative, 5, I'm sorry, over 15, which produces 1/3 or 0.33, okay? So on your Z-score chart, just briefly, I'm going to get mine out too. Okay, I'm going to get my Z-score chart. I love Z-score charts there. Z-score chart. We're going to find what values are 0.33. Okay, in fact, I'm going to do this just so we can see here. Z-score table. Pull this up. Again, my whole idea is to look on the outsides, right? I can look on the outsides. I should be good to go. Okay, so I'm actually, there we are. Perfect. Okay, so I'm going to do this. I'm going to minimize this here. Exit out of that. Come to that. There we are. Okay. So let's go, not that one. I want to get my calculator. Let's go. There we are. Okay. Let's go here. All right. So I'm going to get my Z chart out just so that you can kind of see here. And what I can see is that 0.33 has a distribution that has a proportion of 0.6255. So the proportion is 0.6255, and we know that that would be the part that is in yellow. So the question is all right, so I found that on my Z-score chart there. What can I do then to be able to solve for the rest of this? So we got so this is the Z-score. We just standardized this. Remember, we talked about that today. 0.625 is my proportion, okay? So this is what's in yellow. The problem is I don't want yellow. I want what's in, I don't want white, right? I don't want to the left of that value. I want what's in yellow. So I could take 1 subtracted from the value of what's in white to get the yellow, because this area is 1. And when I do that, I end up getting, should get 0.375. So the answer for the probability of IQ being greater than or equal to 105 is 0.375. Okay. Now, with context, what we could say is the probability of an IQ score being greater than or equal to 105 is 0.375. This right here is really saying that. That right there is kind of counts for that. We might want to establish context once throughout the course of this problem in regards to the whole problem. For instance, let's see if I can find it here. I might want to say when we're in regards to the distribution of scores for people over 16 years of age on common IQ test, we found that the probability of an IQ being greater than or equal to 105 equals 0.375 or 37.5% of people in that case. So that would be, again, just some ways that you could write this and kind of go from there. So the next part I want to kind of address is this idea. Now that you know kind of context, now you know how to do that, we're going to go to this next one, and I'm going to do it on my calculator. Now, let's do it on our calculator. Let's get it, and then we'll come back. So, again, draw it. Make sure we draw it. But it says, what is the probability that the average IQ score on this test of an SRS of 60 people is 105 or higher? So this one, oh, goodness, y'all. Yeah, this threw us off, didn't it? Because it's pretty much the same question on C. It's bringing it's bringing some stuff in there. Yeah, doggone it. That's incorrect. Okay, so let me give you That's a bad problem, y'all. My fault. I thought we were talking in terms of the same thing when I checked it. My fault. Let's say we're doing the same one, okay? And on C, if you put this down, I'll count this on your actual sheet that you need to turn in. That's my fault. We haven't really discussed the SRS, simple random sample yet, but we will. We will later on. But let's say that we're trying to figure out what the probability is that an IQ score could be between 90 and 106, okay? So what we're saying is that from 90 is my low, 106 is my high, my mean is still the same number, which was 100, and my standard deviation is 15. We're going to go to paste, okay? Press enter. And we find that the probability of getting an IQ score between 90 and 106 for people that are over the age of 16 is 0.403, right? Okay, so let's come to this here for a second because I think that this might be of help to you. There are some things you need to know, and we're talking about this idea of a proportion. Go here. Just a couple things we want to address. So let's talk about this here. Let's talk about oh yeah, okay. So first off, we want to draw the graph, right? Okay, we got the graph. We've got 100. The standard deviation's 15. Okay, we know that. So we got 115 here. We've got 85 here, right? And we could just keep going. So we got 70 and 130. So what we're saying is, what is the probability between 106, which is about right here, and 90? Right here. So we're trying to find the area of this. You could find the z-score of 106 and find the probability, right? So find z and then into probability. And you could do it for this too with 90. You could find the z and z-score and find the probability. And just remember that when you do this probability, you would subtract this one from this one because this would be the left of that line and this would be the left of that line. So take the larger minus the smaller to get in between. You could do that. However, I took the route of doing it on my calculator. So let me just show you what's expected. First thing is you've got to write lower bound, comma upper bound, okay, comma mean, and the symbols are sufficient, okay? So I've got to establish what I'm doing. The next thing I've got to do is go normal CDF, comma 90, comma 106, comma 100, comma 15. I've got to actually write that out. Then I need to say that the probability of these values, this is context here, okay? This could count as partial context of this specific problem. 90 x is greater than 90, and it is less than or equal to 106, okay? And I think since it's between two values, I think we can go put both of those there. And we said it was 0.403. So the proportion of this would be here, and you might want to just say when looking at or when seeing that the proportion of individuals IQ scores between 90 and 106, we found that 0.403 is the proportion of individuals with an IQ between 90 and 106. I kind of said it again 2 different times, but anything along those lines establishes context and goes from there. So on those, I'm sorry again, B, C, and D, that's really my fault. The simple random sampling was included, and I was just assuming that we were good to go on that. So if you want to include this one here, that's fine. Finding the area there, and we'll go from there. Those are great questions, y'all. I appreciate it. My apology on that. I thought we were good to go. I thought I did that one, but I think I messed up on what I was looking at there. All right, all right. Let's go to. I think I might have lost my. All right, let me do this. Let me go here. If we have any other questions, we can go over a practice test there. That might be good as well. Let me see here, see if there's any other. Okay, so when you used your calculator, you got 0.02. Yes. Okay, yeah, I'm answering chats here. Let's look and see real quick. I want to make sure on that. So from 90 to 106, right? Maybe I plugged it in my calculator wrong. I'm hoping I didn't mess up there. We'll see. Maybe I did. So check my calculator. Someone just said that they messed up on what we did there, so I want to make sure. 90 would be my lower bound, 106 of my upper bound, 100 is my mean, and 15 is my standard deviation. Be careful. I think I had printed that out right or put that down right. Check me on that and make sure. So I think that is completely right on that. Again, check me on that, and if not, then we could go through that together. But yeah, so that's how we would do that there. Okay, at this time, what I'd like to do is kind of transition to multiple choice. And in multiple choice, we're going to just kind of go through a couple of problems here. And I'm still trying to figure out, for some reason, it is not wanting to pull up the, let's see here. Okay, let's see here. Okay, right now I'm going to pull up one of these. Let's see here, one of these test reviews, and just kind of throw you through a little bit of a practice test. See if you can do that there while you're writing some of this stuff down. Perfect. Okay, so this is what I was looking for. This. Okay, so couple of these problems that we're going to look at may not be exact, okay, in terms of what you'll see tomorrow, but it definitely is a good start. Okay, so as we go through some of these, maybe some of them are, maybe some of them aren't, but it is a good start for what we can expect on there. Okay, so we remember normal distribution has the following, right? What if I had something that looked like this and said this was at 0 and this was at 1, and let's say that this was in the middle at 0.5, you know, and it doesn't matter the height, right? And it goes up and then it comes down, and it kind of continues, right? So what do we do on this? We know that this area on the inside is 1. We know then that it is a density curve. But the question becomes, what do I do with that? So I want you just to kind of take a mental image of this, because I'm going to have to go back and forth. I don't think I can take a screenshot. Let me try one more time. Try to maybe take a screenshot of this and then transfer it over. Let's see if I can maybe put that on there. If I can, that would be glorious. Glorious. All right. Let's go here. Okay. Sorry about that. Coming here. Okay, for some reason it won't let me do it during this live broadcast. I don't know if it's something with the program there, but what I can do is just kind of show you the question, and then we'll just bounce back and forth, okay? So as I do this, this might be a good idea to just kind of try them out and even pause the video and see if maybe you could take this practice test that's here. This, again, includes some good stuff in it. Maybe tomorrow in class, we can go over not in class, I'm sorry, but in the study session, we can go over like number 13 together. That might be a really good problem to kind of hit on and go from there. But in addressing the picture that I just wrote, the picture I drew that down there, remember that it kind of had this weird picture, right? Let's talk about what that's doing. Okay, so first thing, is it skewed right or skewed left? And we can automatically eliminate the fact that those two would not be, these two would not be true, right? Can't be true. As far as the symmetric, whether it's symmetric or not, we know that if the mean is right inside the center, then we can assume that it probably looked pretty symmetric, meaning that the mean was about 0.5 of that total 1. So we can assume that probably the density curve is symmetric, right? We'll come back to that. The one that really gets everyone is D. Is the density curve normal? Well, we remember that this picture, when we analyzed it, right, had this, it was weird, right? So it kind of started here right at 0 and then went up. And let me show you one more time just so you can kind of see here. So it kind of went up, right? So it started at 0 and went up. Notice that it was not bell-shaped, right? And so since it wasn't bell-shaped, we can't assume that it's normal. Even though it may look symmetric, it may look kind of normal, we can't assume it. So because it's symmetric, we would say yes to symmetric, but we can't assume normality, right? Because we don't know the 68, 95, 99.7. And we also don't know, like it's not bell-shaped. So we're gonna say that it's no to that normal that's there, okay? All right, so that's question number 1. And I am gonna address the questions that are here. Okay, let me go back to perfect. Okay, so let's go to this one here. And I'm going to go back to that 105, 100 problem. Someone on the chat's telling me that something went wrong with that. And so I want to do it on my calculator and just see, did I get that one wrong on that? Or maybe something was up with that. So I will come back to that. Number 2 says the density curve shown in question 1, which statement is true? Is the mean greater than the median? Well, if it's symmetric, right? We already answered that. The mean and the median are not greater or less than, right? That the mean and the median would actually be equal, right? Right? Because if it's symmetric, we know the mean and median have to be equal to each other. So my answer on that by default would be C, right? Okay, the next one states, suppose that 16-ounce bags of chocolate chip cookies are produced with weights that follow a normal distribution. With mean weight of 16.1 ounces and a standard deviation of 0.1, the percent of bags that will contain, what are the percent of bags that will be contained between 16 and 16.1? This sounds very similar to me. You could actually draw this out, could you not? All right, so watch this. I'm going to kind of draw this out. So take a mental image or an actual snapshot of that. I'm going to use this here. So we got 16 and 16.1. So what percentage between 16 and 16.1? So our x value, this is really what we're finding, right? Our proportion of x is greater than or equal to 16 and less than or equal to 16.1. So what we've got here is we've got this normal distribution curve, okay, where the mean is a value of 16, and we add 0.1 to get 16.1. We subtract 1 to get, or 0.1 to get 15.9. And then it just keeps going, right? 15.8, 16.2. We know that we're trying to find the area that's here and here. Now, you could use your calculator, which is the normal CDF there, and go lower bound, upper bound, mean, which is 16, standard deviation is 0.1. However, we remembered that 68% of the values landed between one standard deviation to the left and to the right. So if 68% fell between 15.9 and 16.1, I'm really taking half of that, am I not? I'm taking half of that 68%. So when I do that, I can assume that 68 divided by that 34 there, let me get this, 68 divided by 2 would be 34. And then we know that the answer would then be, I'm sorry, 32. 68 divided by 2. Oh, hold up. Oh, yeah, 34. There it is, which is C. Let me post that up here so you can kind of check that out. And so what we can then say then is, okay, we know the answer has to be 34 because it's half of whatever the 68 value is. Okay, continuing on question 3, approximately what percentage of the bags will likely be underweight? So that means that's less than 16 ounces. Well, if 16 ounces, and it actually, did I mess that up again? Dadgummit, I did. I wrote that down wrong. 16.1, sorry, y'all. This won't let me screenshot these. And so my apology on that. 16.1 was the mean, right? So really, it would be, I think, the same answer because I just all I did was shade in the wrong region. Let me show you. Sorry about that. I'm trying to remember them and then kind of go over. I've got so many screens coming up here. All right, and I know it's approaching 9:30. Feel free to come in and hang out with us or leave whenever you need to. I just appreciate y'all for showing up, so thank you for that. So let me redo this. It's the same answer. You'll see why in a second. 16.1 was the actual. This was the mean, right? So this would be 16.2, and this would be 16. And so the question is, and I want to make sure I read it completely right on this. What percentage of values are between 16 and 16.1? I just got to the wrong side of my mean here, right? So I'm really looking at for this one, but similar to the fact that from 16.2 to 16, that value is 68%. So in halving that, we would get what the area is between 16 and 16.1, and that area would be 34. Now, this does launch me into the next question, which asks me what percentage of values are underweight, which means what percentage of values would actually be in the white area, less than 16. Well, what we can do is, and we could say probability of weight, right, being less than 16, right? That's really what we're finding here. And we could find that by doing the same rule. If 68% is between 16 and 16.2, we know that the rest of the data, which is 100 minus 68%, would be 32. If I divide that by 2, I would get 16% and 16% to the left and right of the one standard deviation. So when doing that, I can then assume that 16% would be less than the 16 weight, or the weight of 16 that was there. Do you remember the M&M activity? That M&M activity is exactly what we're utilizing this for moving forward, okay? All right, good question. Woo, we are rocking and rolling. Okay, so let's do the next one here, okay? Thank you very much for sticking with me. You 10 viewers are awesome. Keep it up. Again, this is a good practice test for you. Hopefully this is helping you out. Okay, so we did number 4. I think we got, what did we get there? We get approximately what percentage of the bags will likely be underweight, less than 16 ounces. I got none of the above, but check me on that. Or hold up, was that 16, did we say? No, 16%. Yep, that's right. Because we said 16% was to the left of that one standard deviation that was there. All right, number 5 is a little different. Which of these variables is least likely to have a normal distribution? This one's a little bit tougher. We're looking for something that's not consistent. Notice here, if you notice on this one, there is, like if I did the weights of 200 of the same candy bar in a shipment to a local supermarket, we can expect that to be pretty much normal because it'll follow kind of a curve shape, one's couple being over, a couple being under. We saw that with the M&M activity. Amount of soda in 60 cups, right, filled by an automated machine. Sure, the weight might change a little bit, but it'll pretty much stay normal. The lengths of 50 newly hatched pythons, again, some may be bigger, some may be a little bit smaller, but it will have a pretty much a normal distribution. You'll have a mean, a pretty good idea of 68% being in the middle, and so on and so forth. The heights of 100 white pines in a tree forest. Again, some are going to be really low, some are going to be really high, but overall, it's going to be pretty close to approximately normal there. So with the ones that might, this again is a little bit tougher question. You have to kind of think about it. But if you think about 150 employees at a local high school, there's a couple that are going to be extraordinary, like extra high, because they've been there longer, they have a higher position, something along those lines. But that would be maybe more of a linear where you have it'd be kind of like skewed to the one way or another, probably skewed to the left, where you have a lot of people down here and then a few that are kind of on the heavier, a little bit more paid more side. Okay. All right. Number 6 says the portion of observations from a standard normal distribution takes values that are larger than negative 0.75. Okay. So really what it's asking us to do is to find the proportion of values when the z-score is negative 0.75. So if I were to draw this here, right? Need that. Don't need that. If I were to draw this here, right? Here's my normal distribution. Here's my mean. This is -1. Negative 0.75 would be somewhere like right in there. So we're trying to look to see what values, and I want to make sure what they said, values are larger than. So if I've got to, on my sheet, find what is less than, and then once I do that, I can subtract, let's take 1 and subtract by it, right? Whatever the proportion is, to find what the true value of the white area is, which is what I'm looking for. So what I'm going to do here is I'm going to take negative 0.75. Okay, I'm going to go to my z-score table. And did I exit out of that? Hopefully I didn't. If I did exit out of it, then someone can maybe throw that out there, what it would be. Let's see here. Oh, I don't need that one. I need the... Sorry, y'all, I'm having a hard time with this. But what I could do is find what the, on my z-score table, and kind of work on that side and find what the proportion is. So let me go to my z table here. Let's see here, z table, okay. Okay, so we're going to go to look to negative 0.75 here. And when we do negative 0.75, we get 0.2296. Okay, is what I got here. So we got 0.2296 is the proportion on this. So 1 minus 0.2296. Okay, so we'll put that here. 1 minus 0.2296 produces 0.77. So 0.7704. That's the area or the proportion of values that are greater than the negative 0.75 z-score. Okay. All right. Did we get that right? Yeah. B would be that answer there. Okay. Look at the next one, number 7. Pull that one up here. Okay. I'm not actually right. Okay. Go here, here. All right. I'm going to do a couple more here. So on number 7, this one kind of talks about, actually I can take it home. I'm going to take it from 7 to 10 here. If I do not address maybe one of the questions that are on the chart there, it's not that I was ignoring y'all. It's hard to go back and forth, and especially today, there's just so much stuff. No excuse, but there's a lot of stuff that people are throwing down there, and then I'm trying to go back and forth to. So my apology there. Sorry, Sweden followers. My apology on that. Hopefully this is beneficial for you tonight. This one, which of the following is not correct, okay? Remember with any of these, this is talking about z-score, and what I would do in each of these cases is just check it, okay? So you could test these by plugging in your calculator. So you would put normal CDF, my lower bound, for this one we put 0, my upper bound, 1.5. So my mean, now if it's a z-score, my mean is always 0, right? So be careful on that. My standard deviation is 1. So when my mean is 0, standard deviation is 1, I'll literally plug those values in. And whatever I get out on that part would be, that would be it. That would be it. I think this one right here, z is greater than, I think you want to check on this one. I don't know which one is correct. I mean, I could plug each of these in. We could look at that tomorrow, but that's how you would approach this one. Over here, this one is talking about in some courses, and like students are graded on a normal curve, all right? Sometimes in college that's the case. But for students within plus or minus 0.5 standard deviations on the mean, they receive a C, okay? And so on and so forth. They receive a B, okay, so on and so forth. The class average on an exam was 60 with a standard deviation of 10. The bounds for a B grade and the percent of students who will receive a B grade if the marks are actually normally distributed are what? So the big thing is to understand that with B, it's 1 to 1.5 standard deviations above the mean. So if I start at 60, right, and I go to 10, right, if it's 1 to 1.5 standard deviations above the mean, that means that I would go add 10, right? So let's actually do this one. This one's a good one. So we're going to go, all right, let's go here. This one's a good one. So we got 60 is the mean, right? We add 10, so it's 1 to 1.5. So we got 70 is one standard deviation, 80 is another. So we got this here, right? Here's our normal distribution curve. And the question is from 1 to 1.5 standard deviations above the mean, okay? So this would be 70 here. And so the question is what are the bounds? I want to make sure I hit that correctly because I'm going back and forth. Okay, yeah, so we were trying to find from 1 to 1.5 to receive a B, the bounds for a B grade and the percent of students who will receive a B grade, the marks are actually normally distributed are what? So we could go from, if it's 1 to 1.5, we would go from 70, and then 1/2 would be 75. So the bounds would be 70 to 75. And how would I figure that out? I would do normal, CDF, right? Because we can do a calculator here, lower bound, upper bound. Mean is 60, standard deviation is 10. And when I plug that in, I'll actually do that here. So second vars will go down, normal CDF. We'll do from 70 to 75. The mean is 60. Standard deviation is 10. I got 0.092% or proportion. So I got C. C was my answer on that one when I did it, and you'll see how I got to there on this one. So let me see here, we got there. So you'll see on this one, that's where we got 70 to 75 is what we're looking at, with 9.19% being the amount of people, or amount of students that will receive a B on that test there. Okay, on this one, number 9, the veterinary bills for the dogs are summarized in the OGIVE below. I don't even know what an OGIVE is. I'm sorry. Estimate the IQR. Well, we remember that IQR is from 25 to 50% subtracted, right? So if I go to cumulative percent, cumulative relative frequency is what we've got here. 25 would be approximately $75. So I would draw one over. I would actually work that out, draw it up. 75% would be about 175. So 175 minus 75 would be about $100 is what I saw. So about $100 would be the IQR of number 9. And last but not least, which of the following data summaries are changed by adding a constant to each data? Oh, yes. Here we go. Okay, by the way, the ones that would change by adding a constant to each data value, the ones that would change are as follows. The mean, okay? Would that change? The mean would change, got me? The mean would definitely change. The median would definitely change, and the standard deviation would also change, right? If you look, again, you would just be adding a certain constant to each value. It changes. Well, actually, hold up. The ones that would change are this and this, okay? Let me show you. This right here is, I'd rather show you the actual example of this, okay? So let me do this. Let me go here. Okay, so let's say that we have this value, right? Okay, and this might be a good example. Let's say we're talking in terms of grades, right? Let's say this was a grade on a certain test. Let's say that I added 5 points to each total. Well, what would happen? The mean or the center would increase by 5, right? The center would increase by 5 because this whole thing, if I added 5 points to it, would increase by 5 to where the new mean would be now 65 if I added 5 points to each score. So would the median, right? Because again, this is symmetric. The mean and the median are approximately the same because this is approximately normal. Now, what about the standard deviation? Well, the standard deviation, if I added 5 to every value, right, what would happen there? That's a little bit tricky. Well, remember when I add or subtract two values, the things that would change are only the center, right? The shape would stay the same, and also the spread. We talked about that, right? Shape and spread would be the same. So the only thing that would change is the center, and the actual spread or the standard deviation would still be 10 on this value. Now, what if I added 5 points and I also said, okay, dadgummit, I've got to then, once I add 5 points, I've got to half these points, okay? I've got to half them. Well, let's talk about what would happen here. First thing, let's talk about center. The center would first be taken, so 60. I would take 1/2 of that center, and I would add 5 points. Now, it depends on what I do first on this, but let's just do order of operations to where I'm going to half them and then add 5 points to it. And actually, let's do this first. Yeah, let's do that. Depending on when I do it, and that's kind of tricky, but let's say I half them, put them in context out of 50 total points, and then added 5. So 60 divided by 1/2 is 30. 30 plus 5 is 35. So what does that say? With center's affected by multiplying, dividing, adding, and subtracting. But when we talk about shape is not affected. Okay, not affected at all. Okay, what about spread? Well, spread is not affected by adding or subtracting, right? We saw that over here. If I move this overall 5, you would have 65 to 75, but that spread would still be, or that standard deviation would still be 10. But when I multiply and divide by values, it will also change the spread as well. So the multiplying and dividing changes the spread. So if I were to half all these values, the standard deviation would go from 10, multiply by 1/2, or just half it, and the new standard deviation would be 5 if this was true up here. So that's how we talk about the effects of center based on center and spread based on adding and subtracting and multiplying and dividing. So as we look at that problem, the only one that is affected by what it gave there was 1 and 2, and so that answer would be E. Okay. Wow. Whew. That was intense, very intense there. Okay, so I want to make sure I hit that one right. 105 is the mean. If man, some of you are still looking at this, which I love. I love it. 6 viewers still, which I appreciate. Thank you all so much. The only other thing I would say here that I might want to do was this problem that I had. See if I can find it. It's that from 105 to getting this thing. 105 is the mean. Okay, so 100. Okay, 105 to 100. Okay, let's do this. Let's talk over. If you had a question on that one that I did earlier where I made it up, come and talk with me on that, okay? Come and touch base with me on that, and we'll be good to go. Other than that, y'all are rocking today. Thank you so very much. Man, I love this group. Y'all really work hard. I know we got after it tonight. I know there were a whole lot of fun and games. I'm sorry about that. But the good news is maybe I can just we'll make up for that a little bit tomorrow too. Got a little cool activity and whatnot, and we'll do that after the test. But if you got more questions, come in the morning, and I'll hold off just for a second. Do a little dance break. If you want some questions, throw those questions out, and we'll go from there. Sound good? All right. So here we go. I put my team on, get my things on. Last time they turned it up. Yeah. I got a question, why they hating on me? Here we go, ready? I got a question, why they hating on me? Oh, I never made one. Never made one. Put my team on, got my whole bitch standing. Oh, what's up? Yeah, oh, what's up? Yeah. When I was 9 years old, I put it in my head, I'm a top of this soul. All right, if you have more questions, we'll nail them tomorrow, okay? Some of the questions that I see on there, we are, I want to address them maybe on a personal basis. I could have maybe messed up a number or something on that. If that was the case, then take that with a grain of salt. I'm sorry, I was trying to go back and forth. There's some things that I'm trying to tweak because there are so many things I'm trying to bounce back and forth to with AP Stats. So I hope you have patience with me. Y'all, an hour and 20-minute podcast. Y'all rock. Appreciate your help, and let's get after it tomorrow. See y'all. Bye.